Okay, let's take a look at what's called boolean logic. Okay, so boolean logic. All boolean logic looks at is if something is true and false. So if I ask you, what's 0.3 minus 0.2, you would say that this is 0.1. And we're going to go with 0.1. And as a side note, this is coded very poorly, and the code I'm doing here in JavaScript is coded very poorly. But I'm keeping it simple so you can see what Boolean logic looks like. There's a lot of other code you're going to have to add to make it look as you want it to look. But for right now, this looks poorly, this looks poorly, but we're just going to go ahead and roll with it. Okay. So something is either true or false. So mathematically, if I say, 0.3 minus 0.2, if I say, oh, that's 0.5, that's false. If I say that's 0.1, that's true. So, and again, as a side note, what I've done is when I reload the page, it'll say correct. Let me break that real quick. So I'll put in some breaks real quick. But what is going on is you're just basically evaluating whether or not the statement is true. So, and let me just kind of give you another side note. You've been working with input boxes, and we'll work with input boxes where you input a value, and then the code checks that value, and then the code is going to check it against conditions, okay? So conditions are basically like, or the word condition, something is conditional. So if I put, say, if var equals ABC, this is the answer right here. And if I put 0.2, so these two don't match, it's not going to evaluate to anything, okay? This is basically, it's either true or false. Okay, so this is true, and this is true, and a 0.2 or otherwise are false. Now, the reason why I'm using numbers is you can use statements, and statements aren't that confusing. The reason why I'm using numbers, and this is kind of funny, there's when my wife was taking math classes, one of her math classes was online, and she had a program similar to your IXL or something like that. It was called MathLab. And what would happen is she'd get a math problem like this, and she'd input it into a box. And so this is where the check would occur. And instead of saying 0.1, she'd say 0.1. And she'd check her answer, and it would be false. Even though 0.1 is mathematically correct, she forgot to put the 0, and it would evaluate to false, and she'd get the math problem wrong. Or if you do something like, remember how code can read spaces? What if you actually accidentally put a space in there? It's still correct, but see, it doesn't do that. And what was funny is this math program, which was incredibly used by many colleges, had this coding issue where if you didn't enter in exactly what was there, it would be marked wrong, and professors would have to manually go back through. Their students would be complaining. So the story is they coded it very badly, like terribly badly. Okay, you're just learning to code. This is like you know how to code, but you're lazy badly. So there are, and we'll get into like how you code something like that correctly, but they coded it badly. Okay, so let's say, so this is correct, but so obviously it's going to read it. You want these two numbers to match like this. And again, I'm using numbers because statements, it'll match the exact statement. But numbers, Boolean wise, right now with what I'm showing you, you'll see how it works. If you were to replace this with a statement, it would pretty much always match. This should work. If I put true, true, it would say correct, even though it's not a math problem. But let's say that I do lowercase t. This should work. It didn't. It didn't work. Yeah, so I need some additional code for it to identify that one is a capital letter and one is a lowercase letter. And we'll get into that later. So I'm going to go with math right now. So what I'm going to show you isn't how you would code it. Oh, let me do the 0.1. I'm just doing this to show you the boolean method. Okay, I'm not showing you how to code this correctly. Okay, so let's say this is correct, right? But if it's incorrect, it doesn't say anything. But let's say that you want your user to know that they are incorrect. Okay, this is what you do. So you add what's called an else statement. Okay, so what an else statement is if these two do not match, okay, the else statement says, I want you to write something else. And you can have it write whatever you want. So like for correct, you can put bingo. And for wrong, you can put wah, wah. Okay, you can have it write whatever you want. It doesn't have to be right or wrong. So let's go ahead and change the answer. It doesn't matter what answer you change, just as long as they're different. So I'm going to change the correct one. So what would happen is you'd have an input box, and it would write to this variable right here. So what would happen is whatever someone puts in will be read through here. So whatever you enter is going to be read here, and it has to match this. So logistically, this is the answer that would change, okay? And you change it, wah, wah. So they got it wrong. Well, let's do it right. Hey, all right, there you go. So let's take a look at some structure real quick. So I have what's called var, and honestly, I can do const, okay? And we haven't gone over these. I'll do them throughout, but you can do const, which is naming a variable. Bingo, you can do const. Another one is let, and they have appropriate usage. Got to do lowercase. There we go. They have appropriate usage. There is difference. There is a difference. var, V-A-R, is going away because it was just basically a shortened variable. But see, what happens is like your MLA project where you're storing last name and first name a ton of times. If you use const and put that above the function, you can always draw the same first and last name, and it shortens up your code. So there's appropriate places where you can use let or const, but we're not going to worry about that right now. So I can just use them interchangeably, or I'll stick with var. Okay, and you see how we have an equal sign here? Now this is where it can get kind of confusing. You can see we have double equal sign right here, okay? Now, the reason why you have double equal sign is you're saying, this is saying if, so I'm naming a variable and it's equal to this. Now, what you have to do is you have to break it out of that structure, and you have to say, here's the variable which is equal to this. So if it is equal, it's a little confusing, but it just takes kind of like, oh, did I put a second equal sign there? And this is similar to a function where you have the brackets. And what you're doing is you're taking this variable right here, okay, you named it right here, you're passing this variable through these parentheses. Now, if you remember a function, or the functions you've been working with, they look like that, right? And that's the structure. You're taking data and you're passing it through. Well, to check a condition, let me put that back. Oh, it's not playing with me. I'll have to rewrite it. So to check a function or a condition, you have to pass through exactly what you want it to match, okay? So if ABC is equal to this, you're going to write bingo. If ABC is, remember this doesn't change if you have an input box, this is going to change. You want to go, well, it's not working. I messed myself up. I didn't put the equal. See. So if you change these, so we're going to put this one back to 0, and we're going to put this one to 0.1, and it goes, wah, wah. But the math problem is correct, right? Because 0.1 and 0.1 are the same thing. So this is where you have to add another condition, okay, which are exceptions. So basically, if somebody enters in data, let's say that you want them to enter in a sentence exactly, but they don't capitalize the first letter or they don't put punctuation at the end. Well, you have to add an exception because you don't want them to sit there and have to like scrutinize the grammar in order to move on. So this is what you do. You add what's called an else if. Okay, so here's what an else if does. It creates an exception, okay? So sometimes I get confused and I'm like, if else, because it kind of goes in this order, but you got to reverse it in your brain and go, else if. So if this is the wrong answer, 0.1, okay, if I put 0.1 up here and I reload, it says correct, because what you've done is you said, if this matches this, okay, so if I go 0.1, if this matches this, right, bingo, okay? If this does not match, I'm just going to make it not match, right? Wah, wah. Okay. Remember, it reads spaces. So we're going to put it back. So you create an exception or an else if. If it equals 0.1, you want it to say, and I changed the wording so you can see the difference. So it's going to write correct. So if I reload, hey, it's correct. Now, again, okay, you're going to have to anticipate your users. So we are just going to copy and paste this, else if, what if they put a space 0.1, okay? So here's this, I'm gonna go in, I'm gonna change this drastically. What if they put a space 0.1? And I'm gonna go correcto, so you can see the difference. Wah, wah, because I put in 0.1, which is wrong. Now, let me change this to a space. So they accidentally put in a space, and it goes 0.1. Correcto. So you can just dream up all of the scenarios where you think your user is going to be wrong with the math problem. And you can write exceptions. Wrong with the data entry, not necessarily if they answer, what is 0.3 minus 0.2. If they put in 0.5, obviously that's incorrect because they're looking for a subtraction. So go ahead and reproduce this, get used to it, and try to write this without copying and pasting. Okay, so do some exceptions, do an else. You can change up the statements to whatever you want. And let's see, make this wrong. Just experiment with it and see what you get. Okay, and see if you can get the actual correct what you want it to write. Okay, all right.